Here we are calculating the number of atoms in the simple cubic, and we have given some examples for the students to calculate the number of atoms in the body centered and the face centered systems. I will give an example how to calculate a number of atoms in a simple cubic system here. Now you can see here a simple cubic system which is shown, and this is the atom which is located on each or visually you can see that how an atoms are arranged here. You can see there are 8 atoms, 4 on the top, 4 on the bottom. Otherwise, you can calculate or count the number of atoms like 1, 2, 3, 4, 5, 6, 7, 8. So 8 such atoms are there in a simple cubic system. So all the 8 atoms, if you place like this, you can see that the adjacent atoms touching each other. So that means this is for our understanding. Actual case is this. So these two atoms touch each other. These two atoms touch each other. Whereas the diagonal atoms don't touch each other. So this is how a simple cubic system will be. And now what we are going to do here is we are going to calculate the number of atoms for a simple cubic system. So this is a simple cubic system, as I said. Now I'm going to calculate how many number of atoms are there in this simple cubic system. For that, I have to do two things. One, how many atoms are there at the corner? That I have to calculate. And then I have to see what is the contribution of that particular atom to that particular unit cell. So first I will take 8 atoms which is located on each corner. So it is very clear there are 8 atoms. So as we previously calculated 1, 2, 3, 4, 5, 6, 7, 8. So 8 atoms I have kept here. And I have to see what is the contribution of this particular atom for this particular unit cell. How I can calculate this? So this schematic will give you an idea. You can see here this is not a complete atom. For this particular unit cell, only 1 by 8 of the portion of one atom is placed here. That means there are 8 such system which is placed adjacent to this unit cell. So that means this corner atom will be shared by 8 unit cells. So for this particular unit cell, the contribution of this corner atom will be 1 by 8, such that likewise there are 8 corner atoms. Each corner atom's contribution to this particular unit cell is 1 by 8. And you can see here that I have taken like this. On simplifying this, you can very clearly show that the contribution or the number of atoms present in this particular simple cubic system is 1 atom. So this is an example which has been given to you how to calculate the number of atoms. And the next preceding slides, we are going to see how many number of atoms are there in two systems. One is body-centered cubic system. In this body-centered cubic system, and the body-centered and the next slide, I'm going to give as an work for the students. They have to calculate, they have to compare themselves for seeing how many methods we can implement to calculate this number, how other students are calculating this number of atoms. You can see here there are corner atoms. In addition, there will be one atom which is center. So that is why it is called the body centered atom. The next system is face centered cubic system. So also a simple cubic system, but arrangement of atoms is something different. You can see here, this will give you a clear picture. If you take one face of this unit cell, you can see here at the center there will be an atom. So that is what it is called as face centered cubic system. Now you can calculate for body centered and face centered. Thank you.